Hello, everyone. Here we go. We are starting objective 4 for this unit, unit 9. And today we're going to learn how to graph the logarithm function. Okay, so the logarithm function, remember, logarithms and exponents, exponentials, are inverses of each other. Okay, that's why we use the rules of exponents all the time when we're solving logarithms, and they are interconnected, right? So this is the general shape of a logarithm graph. Okay, so you have a nice smooth curve. It's continuous. There's no break. So it's a nice smooth curve for a logarithm function. It depends of the base. If you look over here in this tiny little detail, okay, if you look over here, it depends of the base. It will tell us if we have a smooth curve in this direction, or if the base is a fraction between 0 and 1, we have a smooth curve in this negative direction, in a decreasing direction. If the base is greater than 1, such as 2, 3, 4, 5, and so forth, then we'll have this smooth increasing curve. If the base is between 0 and 1, such as fractions, we'll have a nice smooth decreasing curve. Now, this fractions does not include 0 and does not include 1 because we know that the base cannot be 0. We already decided that a long time ago. The base cannot be a 0 nor a 1. So it can be fractions such as 1/3, 1/2, 1/4, okay? So that's going to determine which kind of smooth curve we'll have. Now notice over here what I just spoke about, exponential and logarithms, okay? Before, if I gave you a function f of x equals 2 to the x power. This was long ago. This was in unit 1, August of 2020, right? Long time ago, and we try to forget all those things that happened in 2020. But if we had an exponential function, we found the starting point. Okay, let's call it h comma k. Since there is no shift left and right here on the x, and there is no up and down shift, our starting point is 0, 0. This would mark our asymptote. It was a horizontal asymptote, okay? It was a x equals k value. That was our horizontal asymptote. Then we would find the base. The base is 2, which is greater than 1, right? And then we would come to our x and y plane. Let me switch my color. We would put the asymptote right here, open, put the little asymptote. We would go 1 point up, okay? And then we would move 1 unit to the right. Let me make a big deal right here. We would move 1 unit to the right, and then we would go up the base, 1, 2. So the base is 2. And we would draw this small, not small, this nice smooth curve. And that was our exponential. Well, a logarithm will behave similar to the exponential, but instead of a horizontal asymptote, it will have a vertical asymptote. So things are going to change slightly, right? So, and here is our logarithm curve. So instead of a horizontal asymptote, we have a vertical asymptote. We move to the right one, we come back to the starting point, and then we go up 1, instead of to the right one, we go up 1, and then we move the length of the base, okay? So we're doing the same thing as we did with exponential, but we're doing a different direction because that's the inverse of exponential, okay? So keep that up here so you can see side by side an exponential versus a logarithm, and then we'll do quite a few logarithm examples for you to practice, okay? The steps are right next to each other, right next to the example right here, and we'll just follow these steps one by one. So for the following logarithm function, graph it, find the x and the y-intercept if possible, state the domain and the range, and find the equation of the vertical asymptote. Okay, so let's follow our steps over here. First, rewrite the function in standard form. Okay, we want to make sure that we see the k. We want to make sure that we see the h. We want to make sure that we see that stretch of a. Okay, so all these values I'm going to highlight. Okay, I want to make sure we see the k, the h, and the a, and the base. I have a lot of details that we need to pay attention. Okay, so let's look over here. Y equals log base 2 of x. I'm going to write how we read it. Y equals log base 2 of x. That's how we read it, okay? So let's identify a few important things. What is our h and k, right? Just exactly what we want to find here. What is our h and k? What is our starting point? Well, since I don't have anything going on here being added or subtracted to the x, and I don't have anything going on here adding or subtracting outside, so that means I don't have any vertical or horizontal shift. So our h and k, let's write it right here. Our starting point is 0, 0. Starting with something simple. Remember, we're not putting a horizontal asymptote, we're putting a vertical asymptote. It says identify and plot the h and k as an open dot. I did that. Identify and graph the asymptote, which is x equals h. This is my h. This is my k. So my vertical asymptote, I'm just going to put asymp, is x equals 0. Is a vertical line. Okay. So let's go ahead and dot it over here. Tells me that I'm not touching the y-axis. That's why when I said find the x and y-intercept if possible. Okay, sometimes it's not possible. Okay, so there you go. I put my asymptote. Okay, I follow step number 1, 2, and 3. I found my starting point, which immediately I was able to find my vertical asymptote, and we draw it on the graph as a vertical dotted line. Determine if there is a reflection, just like when we had parabolas. Let me go ahead and take this thought. Just like we had parabolas, sometimes if our y equals x squared, if that stretch was positive, we opened up. If that stretch was negative, we opened down. Just like a reflection with a parabola, same thing here. If our a value is negative, right? If our a value is negative, we're going to cross the x-axis, just like a parabola. If the y value, I'm sorry, if the negative x term, if the x term is negative, that means we're going to cross over the y-axis. So when I look over here, my invisible number 1 in the front is my a value, which is positive. So there is no reflection at all. We're just going to keep the graph smooth the way it is to the right. Okay. Identify and plot 2 key points plus the y-intercept. I'm going to say if possible, because sometimes it's not possible. Okay, because it's right on the top of the asymptote. The asymptote is on the top of the y-intercept, the y-axis. So we're going to identify and plot 2 key points. Remember the pattern. We move 1 to the right. We used to go up for exponentials. So we move 1 to the right. It's our first point. We come back to h and k. I'm going to switch it to blue so you can see my movement here. I come back to h and k and I'm going to go 1 up, and then I'm going to go the distance of the base. Let me put B for base. Well, the base is 2. We can see it right here. So I'm going to go to the right 1, 2, and that would be my second point. My first point is always to the right of the asymptote. My second point is up the asymptote and to the right. So now we can go ahead and draw. Let me go back to red. We can draw a nice, smooth, continuous curve going to the right. We started coming down here, right? From the negative direction here, and then we start going to the right. We're going to positive infinity on the x-axis, but we're also going upwards, okay? So that is our curve. The x-intercept is very visual. It's right there, is 1, 0. Our y-intercept, we have none. So let's write none, because the asymptote is on the top of the y-axis, and we're never going to touch the asymptote. The domain, we labeled it already, okay? We are starting here as 0, 0. It's our starting point, but we are not touching it. So we're going to have to put a parenthesis. Let me go ahead and make a big deal here on the side. For some of you that sometimes forget, we use parenthesis to show not including. Or sometimes we can say including, not including, including or not touch, right? We're not touching the asymptote at 0, 0, so 0, but we are going to the right. We're going to the right forever, so positive infinity. The range, we always read from bottom up, so negative infinity, and we are going up forever. So the range is a smooth curve that goes down forever and goes up forever. A vertical asymptote, we already decided, is right here, x equals 0. So there's our graph, okay? If you want to double check that point right there, 1, 0 is correct, if you plug in 1 for x, remember our function is log base 2 of x, right? If you plug in 1 for x, I wonder what you're going to get for y. Why don't we do that just to make sure we remember how to evaluate? So if I plug in 1 for x, I'm going to get y equals log base 2 of 1. So let's ask ourselves, 2 to what power will equal a 1? 2 to what power will equal a 1? Ask yourself, what power would that be? The y value has to be what? The y value would have to be 0. Makes sense. I plug in a 1 for x, I got a 0 for y. So you can always double check by evaluating. I guarantee you that 1, 2, I guarantee you that 1, 2, if you evaluate, if you use the evaluating idea here, will give you a true statement, okay? A true answer. Okay, let's continue on the graphing. I don't want to do a ln, okay, which is the natural log yet. So I'm going to pause on number 2 just for a minute. Let's go for number 4, okay? Then I'll come back to up there. Let's go to number 4. So number 4, when I look at it, make sure I have a red color right here. Yep, that's correct. When I look at it, I have f of x, which means y as well. I have that 1 minus the logarithm. We often put the k value in the front. Well, we often put it here in the back, but sometimes we put it in the front. So this is my k value, not my a. My a is a multiplication, not an addition. So this is my a value. Right here is invisible 1. This is my base, and this is my h. So you need to understand that sometimes we put the k value in the front. Just like if I was doing y equals 2 minus x squared. Do you see the difference right there? Y equals negative x squared. The 2 is positive. It was positive to begin with. We just need to put it in the right place, which is in the back. And that negative 1, which was written right there invisibly, is still in the right place. So our k value sometimes can be written in the back. Sometimes we can write it in the front. It is still a k value. I'm not moving it over across the equal, okay? I'm not changing across the equal. It's still on the same side. Same idea here. I can rewrite it to help you see it, but this is simply f of x equals a negative stretch of a times the logarithm of base 3 of x plus 1 plus our 1. So the plus 1 is the h, the plus 1 is also the k, and our negative 1 is our stretch, okay? All right, let's start by identifying, let me do some of the work here on the side. Let's start by identifying our starting point. Take a look at over here. We have a plus 1, so it has to be a negative 1. That's what it would zero it out here if I plug in a negative 1 for x. And our k is positive 1. So I have negative 1, 1. We're going to put a vertical asymptote. Let me go ahead and draw it over and over so we remember. It's not horizontal, it's a vertical asymptote. So negative 1, 1 is right here. Okay, we have to put in the right spot. Now, negative 1, 0, negative 1, 1. Let's go ahead and draw our vertical asymptote. This is a vertical line. Remember, our vertical, let me just V A. Our vertical asymptote is x equals our h value, which is -1, which answers this question down here, x equals -1, okay? All right, let's see if we can find what the base is. The base is a 3. Our A value is -1. So all these 3 pieces of information are super important for our pattern here on how to graph it. So I'm gonna go drop. So there's a reflection, right? There's a negative, is it a reflection? Yes, it is a reflection. I'm gonna move to the right for my first point, which it never changes. I'm still gonna go here to the right. Now you're asking yourself, do I go up? Is it a smooth curve going up or is a smooth curve decreasing? Why don't we go back and refresh our minds just a little bit? Is it up here? Okay, on our notes. It says right there, okay? Across the x-axis, if our A value is negative, right here. And then I talked to you about the parabola, okay? So our A value is negative. So that means we are reflecting our curve across the x-axis. So instead of a curve that is going up, increasing, it will be a curve that's going down. So from my H and K, instead of going up, I'm going to go down. And then, let me show that in blue. Because our A is negative, I'm going to go down and I'm still going to move to the right the base value of 1, 2, 3, which puts me right here. I move 1, 2, 3. But notice that I went down instead of up. So my curve is a smooth, decreasing curve forever. Okay, well, it's not super smooth here because I'm not good with this program, but there we go. Okay, so there's our decreasing curve. Okay, we are going down, but we're also going to the right. We're going to the right, but we're going down. We're going up forever to positive infinity, but we are not touching the -1 here. It's our barrier, is our asymptote, okay? So we can easily visually identify 2 important things. The x-intercept at 2, 0, right there, that's 2, 0. And we can easily identify our y-intercept, which is 0, 1. Okay, so identify my x-intercept and my y-intercept. The domain, we already have it all labeled. We are not touching our vertical asymptote right here of -1, but we are going to the right. Our range is always from lowest to greatest, so it's a smooth curve that forever goes down and forever goes up. Okay, so there it is, our answers for the logarithm graphing. So let me do a quick recap here. If A is greater than 0, we're increasing. If A is less than 0, negative, we are decreasing. Okay, so just keep that in your mind so we can do another one. I think we're ready to go do one that the students are kind of scared to do, which is the ln. Let's talk about it, okay? Question number 2. When I'm talking about the ln, we're talking about natural log. So let's see in another way. Let's take a different look. This is y equals negative, invisible 1, log base e of x plus a 1. Now, some students get confused. They say, Ms. Myers, is that 1 my h or my k? If it was the h, we would put in parentheses, okay? Every time we want to show that is an h, we'll put it in parentheses. We won't leave it just hanging out like that, because how are we supposed to know if it's an h or k? So we make sure that we put h's in parentheses. Okay, let me see another example to clarify that. Right here on question number 5. Do you see that there is no parenthesis there? So it makes me believe that this is a k value, not an h value. Okay, if it was an h, we would have put it in parentheses, just like we have it here. Okay, all right, back to this. So let's go ahead and identify our starting point. Let's put the work here on the side. Our starting point is, that's not our H, so there is no H. Our 1 is our K value, 0, 1. Let's identify our stretch, shall we? Or our base, doesn't matter which one is first. So we have a -1. So that means our function is going to decrease this. Sorry, it's not a perfect smooth, but it's going to decrease. Let's find out the base. The base is E, which is approximately 2.718 ... forever. So it's bigger than 2.5, but smaller than 3, okay? It's okay, we're just gonna approximate the correct location of E, but we're gonna just try our best here. So I have my starting point, I have our H and K, our base, we have everything we need to get started, okay? Let's go ahead and start with 0, 1, right here. Let me use blue, let me use blue. So 0, 1 is our H and K. Let's draw our vertical asymptote, which happens to be right on the top of the y-axis. We always move 1 to the right. No matter what function we're doing, we always move 1 to the, well, doesn't matter what A is, we always move 1 to the right. Now, I don't think I said that right. Yeah, it doesn't matter what A is, we always move 1 to the right. Now, because A is negative, it determines if I go up or down, right? So I'm gonna go down, let me show it in red. So I'm showing that I'm going down because my A is -1, and I'm gonna count the base roughly 2 and a little bit more than half. So from here, I'm gonna go 1, 2, a little bit more than half, but not quite 3. So let's put it right here and let's label it E. So let me switch it to blue. That's my point right there, and I'm labeling it E. Now I'm going to put my smooth curve because it's a decreasing function, cutting right here through the x-axis and going forever. Here we go. Okay. We do have a x-intercept, but we don't have a y-intercept because we have an asymptote right on the top of it. So how do we show the x-intercept? Precisely what it is. It is E, 0. That's what it is right there. We don't need to put 2.7 because that's not true. We don't put 2, we don't put a 3, we don't put 2.5. We put exactly what the base is. It's E, 0. Okay. We don't have a y-intercept. There's none. We have the domain is already labeled, and it has to do with our H and K. We are not touching the 0. Okay, right here. We're not touching the vertical asymptote, and we are going forever to the right. We are going down, okay, on the right and down forever, but we're also going up forever. So our range is, oh, snap, sorry there. Okay, our range is -infinity. I gave you plenty of time to figure out. -infinity to +infinity, and our vertical asymptote is x = 0. Okay, so we've done a few. I think that is plenty of time. I've done number 1. That was a positive A, so we did an increasing logarithm function with a base of 2. I did example 4, sorry. I did example 4 and example 2. I would like to leave those 2 examples for you to do it. So this is all on you, and this one is all on you. Okay, I will also come back to it in class. I will get you started with your H and K, just to make sure you have the correct location of your H, your starting point. So your starting point is at 2, 1. Your A value is a positive, so we're going to be doing that nice increasing logarithm function. And our base is 4. So I would like for you to give it a try. We're going to definitely check all this, okay? And let's check one more time here that you have the correct H and K. So your starting point should be, there is no H. If there was, we would have put it in parentheses. the k is a 2. Your a is also a 1, so you have this increasing function. And your b value is a 4. So please give it a try. You'll see a slight difference between 0, 2, because it's a vertical shift. You're raising the function up to 2. And this one, it's a right and up shift as well. Okay, so things will change. And we'll go over in class as well. So good job on this one. I'll talk to you later.